We are Group D1, and our topic is colorectal cancer image classification and segmentation. Here's our outline. First, we'll introduce this project, and then we will have two tasks. First is classification, and the second is segmentation. Let's start the first part. Here we use the dataset. This dataset, and this dataset is a segmentation competition dataset in 2015, but it also contains the label of image. And this dataset contains 85 for training, 80 for testing image for two classes, and it also has its mask. In image preprocessing, we do the following things. For the segmentation, we patching each image into some different image with size 224. And also we handle the mask. Since the mask is an image with label from 0 to 9, but we only want to recognize where is the gland or not. So we sim all label greater than 1 to be 1. And for classification, we only simply do the resize. And also, we use a random augmentation, which is randomly use some classification technique with randomly give scale, such as rotation, contrast adjustment, and so on. And finally, for those tasks use pre-trained model, image normalization is used, where the mean and the standard deviation is provided by the model.
Our classification experiment. In this experiment, we talk about first experiment. The first experiment is how the NM models affect performance. The second experiment is how one model and ensemble models affect performance. The third experiment is how residual network affect performance. Finally, the experiment is how one shot and fail shot affect performance. We talk about our models affect performance, and we compare a lot of the models, and the models is loaded by this library, TIANN library. And we know that model selection is an important skills in machine learning. So this experiment is meaningful. We compare its models in this experiment, and we can find that on the reference that if we use complex models such as swing transformer, then it can quickly converge, while if we choose simple models such as ResNet 18, then we may not converge on this dataset. Second, we talk about how one model and ensemble model affect performance. We compare four models. That is ResNet 18 model average, random forest, and audibles. As we can see, if we use ensemble method in this experiment, it performs balance than one model. Third, we talk about how residual network affect performance. We found that our image have third character. That is, the image have high precision, specificity, and noise labeling. Since the image have this property, then it is important how we choose our residual network. We use four type of residual network. That is basic residual, alpha weight residual, preactive residual, and get residual. As we can see, the get and alpha weight residual perform bad than the other.
one-shot vs 5-shot experiment. And since there's less data in medical image, so we need to use this kind of technique. And since there's less data, so we need to use image augmentation to prevent overfitting or underfitting. And as we mentioned previously, random augmentation is used here. And for the embedding model, we use AlexNet and ResNet 18 as our pre-trained embedding model. And for the structure, we use the Siamese network, which is like right picture here. And these two convolution network has the same weight. And for the loss function, we use the contrastive loss here. Okay, here is our result. And from the result, we make the following conclusion and discussion. First, ResNet 18 can reach a high performance, which is near the normal ResNet 18 with only few image. And second, AlexNet performs worse in both training and testing with more training data. Like here, it only has 54.1% accuracy in 5 shots, but it can reach 60.4% accuracy in 1 shot. Here we guess this is because the model is too simple, so it cannot get feature, or it need more epoch to train. Third, the best threshold of AlexNet is far away from half of margin in loss function, which should be a normal threshold for determining whether two images are same class or not. And finally, there are more experiments we can do in the future. That is to use dimensionality reduction technique or directly modify the final fully kinetic layer in model to be less output dimension.
Let's talk about our experiment in segmentation. We do the experiment with the package segmentation models, which provide modularized structure for coding. They also provide multiple encoder and decoder structures, such as DeepLab v3, FPN, and etc. Let's take a brief look at the result. UNet performs well on the dataset. It reached 0.98 in the dice loss, and its predicted mask captures the cancer correctly. FPN also performs well on the dataset. It reached 0.97 in the dice loss. In the end, we will show our result here. Let's talk about conclusion. There are many people have colorectal cancer in Taiwan, and the UK National Health Service research find out that when doctors doing their research, there are false negative rate 4.4%. There's a lot loss in our research. So we want to use AI to assist doctors in interpreting medical images. We found out that AI can perform very well on classification and segmentation. So we believe that this experiment can help doctors to perform well. Thank you for your attention.